Hello, this is a walkthrough for the GCSE maths paper from the WJEC board. This is intermediate tier and this is paper 1, a non-calculator. 80 marks available and we've got an hour and 45 minutes or 105 minutes to do that paper. Onto page 2. Notice that we've been given some formula here to help us with the calculations that we might need to do later on. Just be aware that they're there, you might recall them later. On to question 1. 3 marks available for this question. It says write 2/5, 9% and 0.3 in ascending order. You must show all your working. So the problem we've got here is that we've got fraction, a percentage and a decimal. And we can't really easily compare them. We're looking at trying to find the smallest number through to the greatest number, as you can see at the bottom. So the easiest way is to usually convert these all to either percentage or decimal. And I'm going to do it to decimals. So I'm going to rewrite each of them in that format. So 2/5, if you don't know those conversions, if you convert them to a number like 10 or 100 at the bottom, it makes it easier. So 2/5, I can turn that 5 into a 10 by doubling it. So if I double the top as well, I get 4/10, and as a decimal, 4 divided by 10 gives me 0.4. And then for 9%, that's just 9 out of 100, 9 per 100. And not 0.9 because that would be 9 divided by 10. This is 0.09, so just be careful with that conversion. So we've now got 2/5 is 0.4, and I'm writing it up here. 9% is 0.09, and 0.3 is already in the format that we want. So the smallest of those values is this one here, the one with the 0 in the tenths column. So 0.09 or 9% needs to go here for the smallest one, and then we're just comparing 0.3 and 0.4. Well, 0.3 is the next number up, and the biggest value is the 0.41, which is given in the question as 2/5. There we are. Okay, we'll move on to question 2. The area of a rectangle is 80 centimeters squared. The length of the rectangle is 5 times its width. Calculate the length and width of the rectangle. So if we label the width as W, usually the shorter side, and L as the length, what we know is the area is given by area equals width times length, or length times width, depends on which way around you want to do it. So it says that the length is 5 times this one. So the length is 5 times the width. So if we keep W as being the width, what we can say is that the length is 5 times W, 5W. Now, if I go back to my formula up here and rewrite that, I've got area equals, instead of W, well no, W will go in there, and instead of writing L, I'm going to write 5W, because L is equal to 5W. So I've now got area equals W times 5W. Now, W times W will be W squared, and times by 5 gives me 5W squared. We know that that equals the area, but they've given us the area. They've said that that's 80 centimeters squared, so we can put 80 equals 5W squared there. Now, we're trying to solve, we're trying to find out how big the width is. So, if I get rid of the 5, I divide by 5. 80 divided by 5, well 80 divided by 10 is 8, so 80 divided by 5 is bigger than that, that's 16, double as. And then I've divided by 5 on the right hand side as well, so that means the 5 disappears and I'm left with W squared. So I've got W squared is equal to 16, and to undo a square, I square root. That will make W squared W, and the square root of 16 will be 4. 4 times 4 is 16. So I now know that W is equal to 4 and the length is 5 times that. It's 5 times as big, so this will be 4 times 5, which is 20. So I've got two values there. Checking, does 4 times 20 equal 80? Yes, it does. So my length is 20 centimetres and my width is 4 centimetres. Question 3 is on algebra. Solve the following equations. So we've got two equations to solve. The first one is x over 3 equals 8. So x over 3 means x divided by 3 is 8. So to undo the divide by 3, I need to multiply by 3. That will make the 3 on the left hand side disappear and give me just x. And then I've also got to multiply by 3 on the right hand side. 8 times by 3 is 24. And that's my answer, 24. Part 2 is a two-layer question. So there's two things that we need to do, two steps. I'm first of all going to get rid of this minus 10. So to undo a minus 10, I need to add 10. So I'm adding 10 to the left-hand side. That's going to give me just 3x. 3x minus 10 plus 10 goes to 3x. And on the right-hand side, I'm also adding 10. 17 plus 10 is 27. Almost there now. I need to get rid of this. This 3x is 3 times x. So I'm getting rid of the times by 3, which is a divide by 3. And that will leave me with just x here. And then on the right hand side I'm also dividing by 3, and 27 divided by 3 is 9, so 9 is my answer. Part B asks me to simplify. This is simplified by collecting like terms. So we're looking for the things that are the same. We've got a 6f here and we've got a 2f here. It's important to note the signs in front of each of the terms. So this is 6f plus 2f, and that is 8f. Then we look at the g's, that's the other two things that are left. We've got a minus 4g and a minus 9g. We need to be careful with these negatives now. So this is negative 4 add negative 9, or negative 4 take away 9. So we start at negative 4, we go 9 more negative, so negative 4 take away negative 9, take away 9 is negative 13, and that's g. I can't go any further. These are not like terms now. The f and the g are different, so that's my answer, 8f minus 13g. Question 4. This is about converting units. It says, which of the following is nearest in mass to 5 kilograms? Circle the correct answer. I need to know how to convert from kilograms to pounds. Now this is a fact you'll either know or you won't know, but you do need to remember this. So this is a fact to perhaps note down if you don't know it already. 1 kilogram is approximately equal to 2.2 pounds. Okay, 2.2. And we want 5 kilograms. So I want 5 lots of 2.2 pounds. 5 times 2.2 is, well, 10 times 2.2 is 22, so 5 will be half of that. So that's 11 pounds. Checking that one of those answers is there, and yes it is, so that's great. The next one is also a conversion. It says, which of the following is nearest in volume to 100 litres? Circle the correct answer. You need to know how to convert litres to pints. 1 litre is like those tall milk bottles, and that's approximately equal to 1.75 pints. Okay, it's almost 2 pints, but it's not quite. So the conversion that we have to remember is 1 litre is 1.75 pints. Well, we want 100 litres, so we want 100 times by 1.75. That should be fairly easy to do. It should be 175, and look, we have got an answer there, so that's great. So do remember these conversions if you don't know them already. Maybe make a note of them. Have a little notebook where you put things that you struggle to remember. You keep them on one side, and when you're doing past papers to revise, you can just refer to that rather than trying to look through for conversions and different things, different formulas. Okay, and it should stick by the time you get to the exam, you should have remembered those by then. Okay, so that's question 4. Question 5 is a problem-solving one. It says Rian is n years old. Samir is 7 years younger than Rian, and Nigel is twice as old as Samir. Write down an expression in terms of n for Nigel's age, and this is important, in terms of n. Our answer is going to have something like n plus 3 or 5 times n plus 3. It's going to make sure that it has an n in it. That's what we want to make sure. It's not going to be a number answer. Okay, so noting down, I'm writing down in my shorthand really what the statement's saying. So Rian is n years of age. Samir is 7 years younger than Rian. Well, if Rian's n and Samir is 7 years younger, we've got to take 7 off that n value, the age of Rian. Next, Nigel is twice as old as Samir. Well, if we know that Samir is n minus 7, Samir must be 2 times that. So we could write 2 times n minus 7, but we've got to be careful for BODMAS, so we put the n minus 7 in a bracket. So I've got 2 brackets n minus 7. That is Nigel's age, and that's what it's asked for, isn't it? Write down an expression for Nigel's age. So it is 2 brackets n minus 7. Question 6. The mean of 4 numbers is 7. What is the total of the 4 numbers? So this is about averages, and when I'm working out the mean, I know that I add up all the values to give a total, and I divide it by how many there are. In this case, there's 4 numbers, so the 4 is what we divide by, and then we would work out what the mean is. Now we know the mean is 7. So I've now got to think about how to find that total. I want a number that when it divides by 4 gives me 7. Well, the other way to do that is to do, well, what's 7 times 4? Well, 7 times 4 is 28. So does 28 divided by 4 equal 7? Yes, it does. And so our answer is 28 is the total. Part B. Find a set of 4 numbers such that their mean is 7, like in part A, and their range is 6. Write your 4 numbers in the box below. So it's got some boxes there. I'm going to save those for writing my final answer in, and what I'm going to do is I'm going to put some blanks here that I can put my guesses in to start with and build up my picture, because I might not get it right first time, but I'll get there in the end. So now if their mean is 7, I could put all the answers down as 7, because that would add up to 28, and then divide it by the 4 numbers that there are would give me a mean of 7. So one thing to just take from part A is the total of my numbers must be equal to 28. So the problem is that the range has to be 6. That means that the biggest take away the smallest, the maximum take away the minimum, must equal 6. So if they were all the same number, if they're all 7, the range will be 0, because 7 minus 7 is 0. So I need to have these 2 numbers being different, definitely, and I need the total to be 28. Well, what I could do is, to start with, is I could put the mean numbers in the middle as being 7, and if I know that the total's got to be 28, then these 2 numbers that I've starred there must add up to 14. So they've got to add up to give 14. So I want 2 numbers that add up to 14 that are 6 apart. So 2 numbers that add together to give 14. It could be 7 and 7, but we know that the range isn't right there. So we could increase these. So let's make one, say, 9, and the other one, well, 5 plus 9 would be 14. And checking now, is 9 take away 5 6? No, it's not, is it? So that would give us a range of 4. so they're not far enough apart. We need to stretch these further apart. So maybe we would try next increasing the 9 to a 10 and decreasing the 5 to a 4 so that these two add up to 14. Are these now 6 apart? Well, 10 minus 4 is 6. That's the range that we can put 10 here and 4 there. Okay, so that's an explanation of my logic. There are other answers that are possible that would also work, but I've tried to make it as easy as possible. I've not tried to be too clever with it. Okay, so we still need to fill in the box, don't we? Because it does actually tell us to fill in the box, so if I don't do that, then I haven't really answered the question. Okay, there we go. Now, down to question 7. Question 7 is based on angles. Okay, and what you might notice in this question is we're going to find that angles A, B and C, but the lines that we've got here are parallel lines. This arrow here and this arrow here indicate that those two lines are parallel, and the double arrows here and here indicate that these two lines are parallel as well. So in this shape we've got two sorts of angles. We've got acute angles being less than 90 degrees, and we've also got obtuse angles, which might be like that. They're going to be bigger than 90 degrees. Okay, and all the acute angles will be the same in this parallel arrangement, and all the obtuse angles will be the same value. Now we've only been given one angle. We've been given the 63, and that I can see is less than 90 degrees, so that's an acute angle. So I'm looking for all the other acute angles that are less than 90 degrees, in other words, because they'll be 63 as well. So A is in fact the same, isn't it? A is an acute angle, so that will be 63 degrees, and so I can write that in my answer there as 63. Now the other angles that we've got are obtuse angles. B and C are bigger than 90 degrees, you can see. So if I look at this line here, this is a straight line. So I know that the full turn round there is a half turn along that line around the point will be 180 degrees in total. So that means the 63 plus the other angle here must add up to 180, and if I take 180 and subtract 63 from it, I should get, well, let's do it properly, 7, 10. So 10 take away 3 is 7, 7 take away 6 is 1, 117. So I know that this angle here will be 117 degrees. And all the other obtuse angles are the same. If you like, you can slide this angle along here, and it's the same as this one. But this is also the opposite angle to C, so that's also the same. So those two angles are both 117, 117 degrees, 117 degrees. Question 8. This is a question on probability, but it also says in the question, in this question you'll be assessed on the quality of your organisation, communication and accuracy in writing. This means logically setting out and showing your working. And on the marks, if you look at the bottom right here, you can see there are 2 OCW marks. These are for your organisation, communication and writing. If you don't do it in a very organised manner, you're going to lose those marks. So these are just bonus marks really. You can get the right answer and still only get 5 marks, but you could get 7 if you show you're working clearly. Now, it says 2 fair spinners are shown below. Spinner A has got 1, 2 or 3 as an answer. Spinner B has got 1, 2, 3 or 4 as an answer. And in the game, the numbers shown by the 2 pointers are added together. In the diagram, the score gained will be the 2 for A and the 3 for 4, so 2 plus 3 is 5. And to get a winning score in the game, you need to score 6 or more. So this wouldn't have been a winning score. How many winning scores would you expect when the game is played 60 times? You must show all your working. Well, we need to work out how many winning scores are possible, because there's lots of different combinations possible. And the easiest way to do that is with a sample space diagram. So, a sample space diagram looks something like this. And we've got B spinner and A spinner. The A spinner has got 1, 2 or 3 as an answer. I'm drawing a proper table so that it's a bit easier to follow what's going on. And B B has got 1, 2, let's move that B bit because it's confusing, isn't it? 3 or 4 as a possible outcome. I'm just going to put B there to make sure we know which one's which. Now we're adding these things together, so I'll put a plus there to remind me what I'm doing, and I'm going to write in a different colour in the table. Okay, so I'm going to use orange. No, let's use black because it's a bit clearer. Okay, so if I score 1 for A and then 1 for B, 1 plus 1 is 2. And if I score 1 for A but then 2 for B, I've got 1 plus 2, which is 3. And you can see that continues, and there's a pattern involved here. And then we go to the second one where A has scored 2. 2 plus 1 will be 3, and 2 plus 2 will be 4, 5, 6, and then 3 plus 1 is 4, 5, 6, 7. So there are in total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 combinations possible. Okay, so we've got 12 combinations possible. So that means there's out of 12, how many of the results are winners? We've got to get a winning score is 6 or more. Well, there's a 6 here, there's a 6 there, and there's a 7 there. All those results are 6 or more. Everything else would not be a win. So there's 3 combinations out of the 12 combinations possible that would result in a win. So the probability of winning is 3 out of 12. Now we can do better than that, because in fact we know that 3 over 12 can cancel down to, by divided by 3, 1 over 4. It's a quarter of the results are going to be a win. Now if I do this 60 times, quarter of 60, or 60 divided by 4, will be equal to 15 wins. Okay, so what I've tried to do is set that out in a really clear way. Now, what could I do better? I could probably put probability of win. So that's told me what the probability of a win is here. I could possibly put sample space here. Change it back to the colour that was used. I could probably put spinner A, spinner B. And what I'm doing here is I'm just making sure that I've given all the information possible there. I've explained at every stage what I've done. I've probably gone a bit overboard, but I'm trying to guarantee that I get those extra 2 marks that are available for OCW. Okay, and I think that's sufficient to get that. Question 9. Express 48 as a percentage of 400. So, as a fraction of 400, 48 is out of 400. And I could divide that. Obviously that's difficult without a calculator, but it's possible. However, we want this as a percentage, not a decimal. So I need to multiply that by 100 to turn it into a percentage. Now, what's quite nice here is I can probably cancel some values out. So changing colour, I can cancel, if I times by 100 and divide by 100, that 0, 0, 0, 0, they kind of cancel each other out. And rewriting that, it's 48 times 1, which is 48, divided by 4. Okay, so I can probably handle that a little bit better. I could do 48 divided by 4 with a long division, but you probably know that that is equal to 12. If you don't like dividing by 4, one strategy is to half it and half it again. So half of 48 is 24 and half of that is 12. So my answer is 12, and I'm just going to put percent there so it's really clear what my answer is. Part B is asking me to share £45 in the ratio 8 to 1. So this is really 8 parts to 1 part, and I need to first of all work out how many the total parts are. So total parts is equal to 8 plus 1, which is 9. So there are 9 parts altogether in this sharing ratio. But I need to share the £45 by those 9 parts. Okay, so we're splitting them up into 9 bits. So 45 divided by 9, if you know your 9 times table, you will know that's 5. So £5 per part. Okay, so each part is worth £5. Here I've got 8 parts, so I want 8 lots of £5, which is £40. And the right hand one is much easier. It's just 1 times £5, which I'm sure you know is just £5. So I've got £40 here and £5 there, and just checking, do these two numbers add up to give me £45? Yes, they do, so we know we've not made a mistake. Part C. Express 1 minus 1 over 2 cubed as a single fraction in the form a over b, where a and b are integers. Integers just means whole numbers, so 3, 4, 5, etc. So I'm going to rewrite this, 1 minus 1 over, and the bit that looks complicated there is the 2 cubed. Well, 2 cubed just means 2 times 2 times 2, and we should be able to work out 2 times 2 is 4, times that by 2 gives me 8. So I'm going to replace the 2 cubed with 8. Now it looks a little bit easier. You might know that what the answer to that is straight away, but if you're unsure, convert the 1 into a fraction out of 8. That's 8 out of 8, that's 1. Take away 1 out of 8, and now we've got 8 take away 1 is 7 eighths. So my answer is 7 over 8. Question 10. A number machine is shown below. For a given input, there will be an output number. The output is then put back in the number machine as the next input. This process is then repeated many times. The first input is 512. What will be the output number? What will be the first output number that is less than 300? Okay. So we're going to start off by putting 512 in here, and we're going to decrease the number by a quarter of its value. So what's a quarter of 512? Divided by 4. Probably, you can either half it and half it again, but if you're not happy with that, you could do long division or bus stop method. 4 into 5, 1, 2. 4 into 5 will go once, remainder 1, and that makes it 11. So 4 into 11 goes twice, that's 8, remainder 3. And then 4 into 32, well, 4 eighths are 32, so it's 128. So outcome will be, I've got to reduce its value by a quarter. So in other words, I've got to do 512, take away that quarter. So 2 take away 8 I can't do, turn that into a 0 and borrow. So 12 take away 8 is 4. 0 take away 2 I can't do, change that to a 4 and make the 0 10. So I've got 10 take away 2 is 8, and 4 take away 1 is 3. And so the output would be 384 on the first go. Okay, that is not less than 300 like it asked for here. So we need to now put that 384 back into there, because it says the output is then put back into the number machine as the next input. So we're now going to have an input. Let's do it in a different colour so that it really highlights it. We're now going to put 384 in there, and we want a quarter of 384. 384, and we've got to work out a quarter of that. That's divided by 4. So 384 divided by 4. 4 into 3 won't go. 4 into 38. Well, I know that 10 fours are 40, so it must be, it's only a little bit below that. So it's 9 fours, which is 36. So it's 9 and 2 left over. And then I want 4 into 24. Well, 4 times 6 is 24, so it's 6 and there are no leftovers. Okay, so, but we've not finished yet because we had 384 and we're now going to take a quarter off, so that means taking 96 off. So 4 take away 6 I can't do, turn that to a 7. 14 take away 6 is 8. 7 take away 9 I can't do, turn that to a 2, and then we put a 1 there, so that's 17 take away 9 is 8, and then 2 take away nothing is 2, and out comes 288. Checking, is this less than 300? Yes it is, so my answer is, sorry I didn't mean to do that, the answer is 288. Question 11. Rotate the shape shown by 90 degrees anti-clockwise about the origin. So first of all we need to think about where the origin is. The origin is where the axes cross. It's at the point 0, 0, the centre of all the axes, if you like. So let's put an X where that point is. That's here. Okay. The other thing it says is it's going to be turned 90 degrees anti-clockwise. Well, if we think about the way a clock goes and go the opposite way to the clock, we want to go in that direction about the point, and we want to do 90 degrees as a quarter of a turn. So we want to be a quarter of a turn anti-clockwise. In the exam, you can ask for some tracing paper, and I would urge you to do this because it will make it so much easier. Rotating without tracing paper is difficult. I'm going to do that here, but I wouldn't recommend that you do it, or if you do, at least check it with tracing paper at the end. Okay, so I will put my X on where my origin is. I will put my tracing paper over. I will again go over where the X is. I will go over, and I'm doing this freehand without a ruler. Okay, I think that's okay on the tracing paper, but when you come to draw your final bit, I'm tracing over it. I want to make sure the corners are right, even if my lines are a little bit wobbly at this stage. Then I put my pencil on the origin, or the turning point that we're going to do, and then I turn my paper anti-clockwise, thinking about what I'm going to do. So I'm going in this direction, aren't I, to be against the clock, and I want to go a quarter of a turn, so my paper should be quarter of a turn differently. So it should come to, it's going to be, I'm going to have to move my paper a little bit because I've not quite got enough room there. Okay, so it should end up, sorry about that, should end up here, like this. Okay, and as I said, it's not so easy to do without tracing paper. I'm just checking that my sides are the right length. Okay, I think this looks right. So checking, all the L shape is only 1 square wide, which is good. It's turned on its side by a quarter of a turn, that's correct. And we've got 1, 2, 3, 4, 5 here compared to the start. 1, 2, 3, 4, 5, great. And then this side was 1, 2, 3, and I've got 1, 2, 3 there, so I know that that is in the correct shape at least. Okay, so 2 marks for that one. And we're going to move on to another question using the same shape, okay, but it's asking us to do a different transformation this time. It's asking us to translate. Now a translate is move left, right, up and down. Okay, so the top number in this -1, 7 tells me left or right, and the 7 tells me up or down. Okay, negative means to the left and positive means to the right. So what I want to do is go 1 left, and then the 7 is a positive 7, so that's up. So I want to go 7 up. And it's important to make sure you get those the right way around. You probably, on this one, if you weren't careful and you picked badly, you'd end up being off the page. So be careful with that. Okay, so we want to go 1 left and up 7. So the next thing is to pick a particular corner. I'm going to pick the bottom left hand corner. I'm going to put an X on my original shape, and I'm going to move that corner 1 left and 7 up. Okay, I'm going to use a different colour here. Let's use green this time. So I'm going 1 left, and then I'm going 1, 2, 3, 4, 5, 6, 7 up, and I've got a new corner there, and my shape is going to be drawn from the bottom corner. I've got 1, 2, 3, 4, 5 tall, 1, 2, 3, 4, 5 tall, and then across the bottom I want 1, 2, 3, and then obviously it's a square wide, isn't it, all the way on my L. Now I've drawn that freehand like I did on the previous one, but please do use, for your final answer, do use a ruler and pencil there. Okay, looking at it, the shape looks the right shape, it looks the same, so I'm fairly confident that I've not messed about with the shape of it, but it is in the right position. It's 1 left and it is 7 up. Then it says at the end, write down the column vector that will reverse the translation in part 1. So how would I go the opposite way? How would I put it back? Well, to go back, I have to reverse the values. So what I've got is, instead of going -1, I'm going to go +1. That's the opposite direction. That means going right 1. And then instead of going up 7, I want to go down 7. Well, I need to do 7, but it needs to be a -7. So I've got 1, -7. Question 12 asks us to express 675 as a product of its prime factors in index form. So we need to know our prime numbers here. Prime numbers are all the numbers that divide only by 1 and themselves, but they do not include 1. So 2 is the only even prime number. Then 3 only divides by 1 and 3. 4 divides by 2, so not 4. 5 is a prime number. 1 and 5 are the only things it divides by. 6 is not. That's an even number, so all the other even numbers now are not counted. 7 is a prime. 9 is not because it divides by 3. 11 is a prime number. Notice I'm ignoring all the even numbers. 13 is a prime number as well. And we could go on, but probably that's enough. You should know those numbers. If you don't, maybe write them down and list them as prime. Okay, so we're going to express 675 as a product of its prime factors. So we want all the numbers that 675 divides by that are in this list. So the method is to write down the 675, and we use a tree. Well, it's an upside down tree really. So 675, I want two numbers that divide into 675. So I'm looking at the number for a clue. What can I divide it by? It's not an even number, but it does end in a 5. If it ends in a 5, that means it will divide by a 5. So I'm going to work out what 675 divided by 5 is, because that's not an easy one to do in your head. So 5 into 6 will go once, remainder 1. 5 into 17 goes 3 times, and that's 15, isn't it? So there's 2 left over. And 5 into 25, well, 5 5s, so 5. So 135 is one number, and 135 times by 5 is 675. I'm now checking, are either of those numbers prime numbers? Well, 5 is, because it's in my list. 135 must divide by 5 again, yeah, because it's got a 5 at the end. So let's divide 135 by 5, because we're going to have to branch out. Once we've got to a prime number in here, we circle it and we stop. We don't go any further with that branch. Okay, so we've got 135 divided by 5. 5 into 1 won't go. 5 into 13 will go twice. Remainder 3. And 5 into 35 is 7. So 27 is fine here, and the number here is another 5. Again, it's a prime number, so I circle it and stop. But 27 will divide. And you might know 3 times 7 is 27. Now they've got quite low numbers. So sorry, 3 times 9 is 27. Now we've got low numbers, it's a bit easier to spot because these are in the normal times table. So 3 times 9 will be 27. And looking at my list, 3 is a prime number, so I can circle it, but 9 is not. So I need to go again with 9. And the only thing is I can divide 9 by are 1, 3 and 9. So it's 3 times by 3 is 9, and both of those are prime numbers. So I circle them, and I've got no more branches now that I need to pursue because they're all complete. So we've done the hard work now. It says express 675 as a product of its prime factors. So 675 is equal to, and I'm looking at all the numbers. I'm going to do them in size order, but you don't necessarily have to. It's just a very organised way of doing it, which might make things simpler in future. So I've got 3 times 3 times 3 times 5 times 5, and the in index form bit means that I need to gather the same numbers together. So I'm just going to say 675 is equal to now 3. We've got 3 3s, so that's 3 cubed, and 2 5s, that's 5 squared. And now it's in index form, and that is the final solution. Part B is relating to a similar thing, and it's saying it's a different number is expressed as a product of its prime factors as 2 cubed times 3 squared times 5. What's the smallest whole number that 360 can be multiplied to give a square number? Now, to have a square number, the powers of these numbers must all be an even number. So 2, 4, 6 or 8. Now, we've got a 3 here, we've got a 2 here as a power, and the 5, in fact, we would normally write a 1 there. Well, we don't normally write a 1, but a 1 would appear there. It just means 1, 5, but we don't normally put it in. So I need to increase these. So if I'm going to multiply these numbers, I need to change any of the ones where the powers are odd into an even. So 2 cubed can become 2 to the 4 if I times it by 2. And 3 squared, it's already an even power, isn't it? So I don't need to do anything with that. The 5 to the 1, that's not an even power. 1 is an odd number. So if I times that by 5, I get it to 5 squared. Now that's an even power. So I need to increase by timesing by 2 and timesing by 5. Well, 2 times 5 is 10. So I just need to multiply that answer, that value rather, there, by 10. So the smallest whole number I can multiply it by is 10. So let's move on to the next question. So question 13. Simplify each of the following. Circle your answer in each case. This is multi-choice. So we're looking at simplifying m to the 4 times by m cubed. When I multiply two same terms but with different powers, what I can do is I can add the terms. I add the powers. So I've got m to the 4 times m to the 3 becomes m to the 4 plus 3, which is m to the 7, and I do have that answer available there. When I'm dividing instead of multiplying, I'm going to take the same letter and I'm going to, instead of adding this time, because this is dividing the whole things, I'm going to take away the powers. So 15 take away 5 is m to the 10, and m to the 10 does appear there as well. Another multi-choice one, let's zoom in a bit more. Write down an expression for the nth term of the following sequence. Right, well, first of all we need to work out what's happening each time. So 4 to 11, 11 take away 4 is 7, so we're adding 7 there. We're also adding 7 there and there, so there definitely is a pattern, and if I was adding 7 more, I would end up with 32, but I don't actually need that. It's not actually asking for that, it's asking for the nth term. So to find the nth term, we take the 7 and we write an n after it. This is like the 7 times table, it's going up 7 each time, and then we need to adjust it. What would be the number that would come before the 4? Well, going back 7 from there would take me to -3. So in fact I need to put -3 there, and that is my nth term. Part C. List all of the integers, that's whole numbers, that satisfy the following inequality. So we've got an inequality here. This means we've got there, reading it out, it's 13 less than 2n less than 19. Well, the fact that it's 2n makes that difficult to deal with. So what I probably want to do is to change that from 2n to n. I'm going to leave my symbols the same. To get from here down to here, I've had to divide by 2. So 2n becomes n by dividing by 2. 13 divided by 2 is 6.5. And then 19 divided by 2 is 9.5. Now I want all the integer values that fall in this. They've got to be bigger than 6.5. Well, 6 won't be, but 7 will. Is it less than 9.5? Yes, it is. That's okay then. Next number up would be 8. That's bigger than 6.5. Is that less than 9.5? Yes, it is. So that's okay. And then we've got bigger than 6.5. Well, the next one will be 9. Is that less than 9.5? Yes, it is. The next number would be 10, but that's not less than 9.5. So these are the only 3 numbers that would work for. Those are the whole number values, the integer values that satisfy that inequality. List AB, sorry, line AB is shown here, is shown below. Using the ruler and a pair of compasses only, construct an angle of 60 degrees at point B. So I'm going to zoom in on this so that it makes it a bit easier, and we're going to use a compass, not a protractor here, and we've got to construct an angle of 60 degrees at point B. Well, we know point B is on the bottom left there, we can read it, so here is where we want to be. I'm going to extend my compass from point B to roughly halfway along the line. Okay, and I put a little mark here to help me decide roughly how far. If I go all the way to A, I'm going to end up off the page if I'm not careful. So I've got about halfway, and I'm going to extend my compass so that it comes here, and I'm going to draw a curve. Now this is me sketching it, so you would be more accurate with your compass, and I'm going to do that, and it's going to come round to something like that. It's going to look like, right, I've drawn an arc. I could possibly come down a little bit further there. Okay, now that is all the points that are the same distance from B, okay, on that line. Next I'm going to go over to that point there where I've just intersected the line. I'm going to put my compass point there. I'm going to keep my compass the same distance, so in fact where it's going to be is, it's going to be here, isn't it? It's going to extend to there because it's the same thing, and I'm going to draw a curve now, something like that. Now I've got 2 curves that cross at a point. Now where that point is crossing, I'm going to have to draw a line. So if you just bear with me, I will draw a shape on there. So let me go up there. I need to draw a line now from point B right the way up to that point. So I'm drawing like that. I'll go through there. I'm just going to extend that back down. And now I've drawn a line that goes through B and up there, and my angle that I've got is, let me just get that back, so that angle there is 60 degrees. If I was to join that point there down to here, I would construct an equilateral triangle. And we know that in an equilateral triangle, we've got 180 degrees in total, but all the angles are the same. So 180 divided by 3 will be 60. That's why this works. Okay, just a little bit further explanation than needed. So part B of the same question also is requiring you to use a compass, and we've got to construct an angle of 90 degrees at point R. So this is not a bisector at the moment because the R is not right in the middle, so we need to find 2 points either side of R that are equidistant. So I open my compasses and I draw a little arc. I'm not going to draw the full circle. I draw an arc there and an arc there. These points are both the same distance, and my compass have just turned round. Okay. Now I've got 2 points equidistant from R. They're both the same distance from R. So I've got this point here and this point here. Okay, so we've got 2 points. We're going to get our compass point and put it on each of those crosses that I've put. So going to this one here, first of all, put my compass on there and stretch it just the other side of R. And I'm going to draw something like that. I'm going to draw an arc that looks like that. Let me just zoom in a little bit more. Okay, I'm extending that down. And then I'm going to go to the other side and I'm going to draw from that point there with my compass not change the diameter of it, and I'm going to draw another arc, and I'm going to draw, it's going to come this way like that, and then the other way like that. Now hopefully this is reasonably accurate, but obviously your compass will be much more accurate than my freehand drawing. And then I'm going to save that. I'm going to put a line on here, so I just need to move up slightly, and I want to go here, and I'm going to draw a line through here, something like that, and I'm a little bit out on mine, but you can see really this should be bang on through the middle. I'm a little bit out, but you get the idea. You go through the 2 points and it should be a 90-degree line that goes through R. Okay. Finally, it's a third question on this, also involving a ruler and a compass. We've got to construct a perpendicular line from point P to the line XY. So what we're aiming to do is to draw a line that goes something like that, where that's a 90-degree angle. But we can't sketch it, obviously. We have to construct it, okay, because it does say construct. That means I need to show construction lines. Okay, so let's zoom in a little bit, and obviously I'm showing you here what's going on. So I'm going to get my compass and I'm going to draw an arc from, I'm going to put my compass point on P for a start, and I'm going to extend it. Y is much further away from P than X is, so I'm going to go as close as possible to X. Right, I'm going to draw an arc and it's going to go here. I'm not going to go all the way round, but I'm going to end up with something like that. So my semicircle would go all the way round, obviously, but I'm just marking where it crosses the Y line. Now these 2 points are important because these are both the same distance from P. So I'm going to now put my compass on P, sorry, on that X that I put there, and then later I'm going to put it on this point here. So starting with this one, I'm now going to go halfway along the line. Halfway along the line. So I'm going to do something like this. A little bit more than halfway, in fact. So I've got to go slightly more than halfway. So I've got an arc, something like that. And then I'm going to go the other way. I'm going to start at this point here with my point on my compass, and I'm going to draw a line like this. Okay, something like that would work. Okay, and then I can see I've got 2 points here and here where these cross. I need to join those with a line. I'll do it, but I suspect mine will be slightly out, but we could try. to give an idea, and drawing it from there. Yeah, I want to go something like that through there. It's not too bad, I think that's okay. And what we've got here is we've got an angle of 90 degrees there, and it goes through point P, which you can see down here as well. So in fact we've constructed a 90 degree as required. Perpendicular meaning 90 degrees, obviously. Okay, so it's important to remember that don't rub out your construction once you've done it. We're not after an accurate line, we're after you knowing the method to produce that line. Get back, save that. Okay. Well, there's a lot of writing in this one, isn't there? So we need to read through the question carefully first of all. So we've got question 15. The shape below consists of a semicircle attached to one side of a right-angled triangle. Okay, so we can see the right-hand triangle on the left there. ABC is equal to 90 degrees. That's A to B to C. The B with a hat on in the middle is the 90 degree angle I've just drawn in blue there. AB is 8 centimeters long and BC is 6 centimeters long. BC is the diameter of the circle, so the diameter of the semicircle, sorry, is 6 centimeters. And it wants us to calculate the perimeter of the shape, and we've got to use pi is equal to 3.14. So the perimeter of the shape does not include the dotted line. It means the curve at the top, the line AB and the line AC. That's the distance all the way around it. Well, probably there's three things I need to know. I need to know those three things. One of them I know is definitely 8. That's important. The other one, the AC bit, I don't know that, but that's a right angle triangle, isn't it? So if I think about that as a right angle triangle, 8 and 6, I can use Pythagoras to work out that side, can't I? And this is the longer side, so AC will equal the square root of 6 squared plus 8 squared, which is the square root of 36 plus 64. Well, 36 plus 64 is 100. Oh, this is good. We haven't got a calculator, but we know what the square root of 100 is. That is 10. So I know that AC is equal to 10. I'm just going to put AC there to make that clear. So we know that that's 10 centimeters. I'm writing it on my diagram as well. Now, we know two of the sides. We don't know the curved side of the semicircle. But we do know the circumference of a circle is pi times the diameter. Okay, for the full circle that is. So for the full circle we would have pi, which they've told us to use 3.14, times the diameter. The diameter is 6. Okay. So I want 3.14 times 6. Now that's a bit more tricky, isn't it? So without a calculator particularly. So if I use the box method, 6, I'm going to use 6 times, sorry, I'm going to do 3 times, not 3 times, 6 times 314 first before I work it out. So 6 times 310 and 4. 6 times 3 will be 18 with 2 zeros, and then 6 times 10 we know is 60, and 6 times 4 is 24. Adding those up I get 1884, and then we don't want 6 times 314, we want 6 times 3.14, so I've got to put 2 decimal places back in. That becomes 18.84. But that's for the full circle, isn't it? And I want half of that, so I need to divide that by 2. Well, it's not too bad actually to do. Half of 18 is 9, isn't it? And half of 84 would be 42, so 0.42, so 9.42. Now that's 9.42 for that bit, so we need to add all these up, and we've got 10, I've run out of room a little bit here, 10 plus 9.42 plus 8, and if you're not sure you could use the column method, but that will be 10, 9.42 and 8, adding them together, that's a 0.42, 9 plus 8 is 17, carry 1, so it's 27.42 centimetres. It does say you've got to show all your work in, and I think I've shown quite a lot of work in there, probably a lot more than you would need, but there are 5 marks available for that, and you'll be getting marks as you go. So if you don't quite get to the end of that, but you've got some of it, you're going to pick up some marks. Note that we are now getting quite late into the paper, so the questions are definitely getting trickier. Question 16. So it says 2 time periods are measured as 4 hours 40 minutes and 2 hours and 50 minutes. Each measurement is correct to the nearest 10 minutes. What is the least possible sum of these 2 time periods? Well, we want the lowest values they could be, and they've been rounded. So we want to take the lower bounds for each. So 4 hours 40 minutes to the nearest 10, it could be 5 minutes lower. So it could be 4 hours and 35 minutes. Okay, notice I've taken half of the 10, that's 5, off my 4 hours 40. And that's a lower bound. I'm going to put that there so that it's really clear. And the lower bound for 2 hours 50 minutes would, again, half of 10 will be 5 minutes. It will be 2 hours and 45 minutes. So those are the lowest 2 values, and if I add those 2 together, I'm going to get the lowest possible sum. So I want 4 hours 35 mins plus 2 hours 45 mins. Several different ways of attacking this. So first of all, 4 plus 2 is 6 hours to start with, and 35 plus 45 minutes is 80 minutes, but 80 minutes is an hour and 20 minutes. So in total, the 6 hours and the 1 hour 20 minutes gives me 7 hours and 20 minutes. And that's my final answer. Question 17, and it's a probability question this. So it says Whitney walks, cycles or travels on the bus to work each day. On any randomly chosen day, the probability that she walks to work is 0.25. The probability that she cycles to work is 0.45. Okay, so let's have a look. At work, the probability that there will be a fire drill on any random day is 0.04. So we've got travelling to work and we've got the fire drill in 2 separate columns, if you like, with the probabilities drawn there. How Whitney travels to work is independent of whether or not there is a fire drill. And we want to complete the tree diagram shown below. Okay, well, we know all the tree diagrams. Each set of branches must add up to 100% possibility or 1. So far 0.25 plus 0.45, that's 0.7. That leaves 0.3 to go in the travel to work for bus. And the fire drill, these are all repeats. There's 3 sets of branches here, but each of them are repeats of the previous one. We know that the total of each set of branches must be 1. So 1 take away 0.04 would be, being careful, 0.96. That would add up to 1 between the 2. And then the other branches are going to be exactly the same. So we need to put 0.96 there and 0.96 there. Okay, so that's a fairly straightforward tree diagram, isn't it? And there's 3 marks available for that. On a randomly chosen day, what is the probability that Whitney walks to work and there is a fire drill? So we need to look at which branches are involved. So we want to walk to work, so we want to go this way, and then there is a fire drill as well, must be here. Okay, so in order to do that, we've come 0.25 chance of walking, so 0.25, and then as we're going across, we're always going to be multiplying. When we're going up and down in this direction, we're adding to get 1, but when we go across, we're going to multiply these two probabilities together because it's one thing and then the other. So we want the probability of there being a fire drill as well. That's 0.04, so we're timesing by 0.04. So I need to do 0.25 times by 0.04. So 0.25 times by 0.04. Not easy that. So I'm going to change that into 25 times by 4, which I know is 100. Okay, but we've got 1, 2, 3, 4 decimal places in here. So instead of 100, I want to put, if I put 100 here, I've got to put 4 decimal places smaller. Well, 2 decimal places smaller would be 1, and then I need to go 2 further decimal places. So 0.1 will be another 1, and then 0.01 is the answer that we want. So in fact 0.01 is the answer. So it should be down here, shouldn't it, that one? So I had room, but I didn't want to get it off the screen. Question 18. This is about measurements and dimension, and it's interesting that they've given us an example here, and what they've got is each of the letters can be is a length of some form. Okay, so D, R and W and L and B and H, they're all lengths of some form, like a diameter or a radius or a width or a length or a base. And it's the combination of those that decides whether this is centimetres if we're adding them, centimetres squared if we're multiplying two things, or centimetres cubed if we're multiplying three things. So it says on the first one, the example that they've given, we've got a length centimetre plus a centimetre, take away 2 centimetres. So that's all going to be centimetres, isn't it? Or metres. So it's going to be a length. Here, if we add these three things together, that's all going to be a length. But then we're multiplying whatever's in that bracket, a centimetre say, by another length. Centimetre times centimetre will give me centimetres squared. Well, that's the unit for an area. In this one, we've got d cubed. That's centimetre times centimetre times centimetre. It's 3 lengths multiplied together. That will be centimetres cubed, which is a volume. And we're adding to it a number times by a length. So centimetres cubed plus centimetre is not compatible. We can't add a volume to a length because they're not the same units. So what we say for that is that that's not acceptable, really. Okay, so I'm just trying to search for the word that they use. So say none is what they're looking for. I was just checking the mark scheme there to what they expect. So none or incorrect, something like that would be acceptable as an answer. Next one, we've got w cubed divided by diameter squared. Again, that's not really compatible, is it? I can't w cubed, the width cubed, divided by a diameter squared. Oh yes, we can do that, because if we've got centimetres cubed and we divide that by centimetres squared, we've got power of 3 divided by 2. We do centimetres, we can turn that into a centimetre. Okay, so it's the 3 take away the 2 in the power. So in fact, that one is a length. Okay, here wasn't possible because we were adding two things of different units together. Here we were dividing, so that's okay. Here on the next one, we've got effectively a centimetres cubed here, and we've got three lengths multiplied together, a centimetre times centimetre times centimetre, so it's centimetres cubed times, take away centimetres cubed, that's a volume take away a volume, which is a volume. Okay, and then on the last one we've got width squared, which is a centimetre squared, divided by a centimetre, which is centimetres. So that is area. No, it's not. Sorry, I made a mistake there. That's not area, it's length, isn't it? Centimetres is just length. Save. Okay. I think we're on the penultimate question now. Express 0.076 in standard form. This means it's got to be 1.23, something like that, times 10 to the question mark, something like that. That's the format we want. This is a very small number as well. So we take the 7 and the 6 and we write them as 7.6. That number must be a number between 1 and 10. And then we're going to do times 10 to that. And I'm thinking about how far I've moved that decimal place. 1 space, 2 spaces, 3 spaces. So there will be a 3 that goes there. But because this is not a big number, this is a small number, we indicate that it's a small number by putting a negative there. So 7.6 by 10 to the negative 3 is the correct answer. Next question is a little bit more tricky. Calculate the value of 3 times 10 to the 17 times by 2 times 10 to the negative 12. We could rewrite this as 3 times by 10 to the 17 times by 2 times by 10 to the negative 12. The brackets aren't really necessary in this case. So I can also rearrange the numbers now. So if I put the normal numbers together, 3 times 2, and the powers of 10 together, that makes it much easier. 3 times 2 is 6, and then 10 to the 17 times 10 to the negative 12, the powers need to be added. So I'm being careful with that negative there, 17 plus negative 12. That's the same as 17 take away 12, which is 5. So I'm changing that to 10 to the power 5. Okay, it is in standard form because the first number is a number between 1 and 10, and then we've got a times 10 to. So that is my final answer, 6 times 10 to the 5. Part C. Calculate the value of 2.3 by 10 to the 4 plus 5 times 10 to the 3. Give your answer in standard form. There's several ways to attack this. Most people will probably convert these to whole numbers. So converting 2.3 by 10 to the 4 is that's one of the powers, so that, and then I want 3 more zeros. So 2.3 by 10 to the 4, I've moved my decimal place, if you like, 4 spaces to make it, and it's a big number, so I know that that's right. The next number is going to be plus, and it's 5 times 10 to the 3. That's 5 with 3 zeros. So over here, I'm going to do column method, 23,000 plus 5,000. Not really necessary because it's quite easy, but 28,000 will be the answer. Now it's not quite in standard form because it wants the answer in standard form. So my number is going to be 2.8, and then I've got 1, 2, 3, 4 numbers afterwards, so times 10 to the power 4. That is the answer, 2.8 by 10 to the 4. Final question, because it says the end of the paper. Phew, we're nearly there. Okay, and this is going to be a tricky question, obviously, because it is the last question. So, let's have a look. It says xy is a tangent to a circle centre O at point A. Now, if it's a tangent to the circle, then a tangent meets a circle at the radius at 90 degrees. Okay, in other words, we've got a right angle there. Okay, and that's going to be important. Angle AYO is 54 degrees. And it says what percentage of the whole circle is shaded. You must show how you calculated your answer. So, probably the first thing I can work out is the angles in that triangle must add up to 180, so that angle there would be 36 degrees, wouldn't it? 36 plus 54 is 90, plus another 90 is 180. Okay. And then the percentage shaded is just a sector of this circle, isn't it? It's a fraction of the whole area of the circle. It's 360 degrees all the way around the full circle, but we've only got 36 degrees. So in fact, we've got 36 out of the 360 degrees times by the area of the circle. So 36 over 360, well, those numbers are very simple, aren't they? So that's 1/10 of the area of the circle, and the area of the circle is pi times by the radius. Do we know the radius? No, we don't, do we? Squared. So we don't know the radius, but if we look at that triangle that we've got here, the OAY triangle, what we've got is a right angle triangle. So I'm going to draw out the right angle triangle very badly, but it'll suffice. I've got 54 degrees there. I've got 36 degrees there. And, oh, it doesn't actually ask us to work out what r squared is, does it? It says what fraction of the whole circle is shaded. So, in fact, we've actually got 36 over 360, which is 1/10. So the only part I actually need is 1/10. I was being too complicated. So the fraction of the percentage of the whole circle is what's equivalent to a tenth. Well, a tenth is 0.10 or 10%. Okay, so it's 10% of that circle is shaded. What tangent property of circles did you use in order to answer part A? Well, I think I said that at the start, didn't I? The tangent at any point is perpendicular, this bit here, okay, to the circle. So you need to say tangent is perpendicular to radius at the circumference. And that's it. There's only one mark for that. So in fact, that wasn't too bad a question. It's a little bit difficult getting that 1/10, and I probably made that slightly too complicated. Okay, so we've come through the paper. We've got to the end. Obviously, you will have a fair bit of time left, hopefully, to go back to any questions that you didn't do, or you didn't do completely, or perhaps you think you might have gone slightly wrong on. You want to have a check over them. If you have got time left and you've done everything, you've attempted every question, what I would suggest you do is not to just stop, but to read carefully through and just make sure you've answered the question the way they've asked to. Anyway, well done. Keep practicing.